Alright, okay. So let's get on to our circular permutation, okay, or the special types of permutations that we need to learn because at some point, of course, arrangement will still be an important factor. So after the combination, okay, we have a special types of permutation, right? So first is the circular permutation and the group permutation. Now I'm gonna be doing a separate video for each. Okay, for now we're gonna be doing for the circular permutation. Okay, so that you can actually digest it properly. All right, so let's say for example, for the circular permutation, okay. So here is the formula for a circular permutation wherein the number of permutations of n objects arranged in a circle is n minus 1 factorial. Okay, so as per our history, it actually came from the n factorial over n, okay, uh, wherein the linear permutation is divided by the number of rotations on a permutation. Okay, in other words, it's just actually rotating. Okay, so basically, it is the same. Okay, when we are rotating it, the same as the circle original when you bend the head to the right. Okay, and when upside down. Okay, in other words, as you rotate it, okay, it's the same. Okay, now what we want to do is to have a reference point. That is why there's a minus one, and then everything else will be changing places. Okay, so that is why there is a minus one there. Okay, so for example, for this one, there are four um, items here. Now, the number of arrangements this can have is actually 4 minus what? Okay, 4 minus, okay, so this is what? 4 minus 1. 4 minus 1 factorial. Okay, so let's say for example, we are having a reference at number 1. Okay, because it goes to 3 factorial. It makes sense that these three items will be only those that will be changing places. Okay, because if we change place together with the 1, it will be the same item. Okay, so we would like to have a reference point 1, okay, or whatever that may be, and then everyone else changes places. So that is why it is 3 factorial. Alright? Or it becomes n minus 1 factorial. Okay, hope that makes sense. Okay, next, let's have an example. In how many ways can 5 different trees be planted in a circle? Okay, so it was given as 5 minus 1 factorial or over 4 factorial. So let's have a drawing of 5 different trees. So we have tree 1, okay, tree 2, 3, 4, 5. Again, we have what? 5 minus 1 factorial. It means that let's have one reference. Let's say the 5 is the reference. Okay, and then everyone else will move. Okay, in a whatever combination or permutation or arrangement that may be. So it becomes there are 24 ways to do it. All right. So I hope that circular um, circular permutation will make sense. So let's have another example here. Okay, in how many ways can we arrange 4 boys in a round table? Okay, so let's answer this. Okay, and in how many ways can we arrange 3 boys and 3 girls in a round table if there are no constraints? The boys hate each other and would not want to sit beside each other, and then boys and girls are alternate. Okay, the 3 boys and the 3 girls form 3 couples and they are to sit beside each other, and all boys and all girls are together. B1, B2 would sit opposite each other. Okay, so there are actually several ways to do this. So let's start with the first one. Okay, for the first one, we have what? There are 4 boys arranged in a round table. So I think we can use the blank page to the next. na lang. Sige. So, in how many ways can we arrange it? Okay, so, number 1, we have what? We have 4. N is equals to 4. Therefore, we have, okay, 4 minus 1 factorial equals to 3 factorial equals to 6. Okay? So, in how many ways can we arrange? Okay, so we have already that number 1, ha? So, number 2, in how many ways can we arrange if there are no constraints? So, for there is no constraint, we have a total of what? 6, right? N is equals to 3 plus 3. So, we have what? 6. Therefore, our item for this one is what? 6 minus 1 factorial equals to 5 factorial equals to 120. So, this one is quite easy, no? So, number 2, ito yung medyo tricky. I hope you follow this through. Okay, so two boys hit each other. Okay, so step 1. Okay, so there are other steps now to do this. Two boys hit each other and would not want to sit beside each other. So, the first thing that you do is to determine if there is a condition like this. First is to determine no constraint first. So, no constraint. So, in a total, no, this will be our total number of combination or permutation or arrangement. Okay, so we have, as per letter A, we have 120. Okay, next is that you treat those two boys each other as one block. It means that they, as if they hate each other, they do not want to be uh, together, diba? Now, let's think of it in a different manner. Okay, let's think of it as they like each other or they would like to sit with each other. Okay, so determine the number of arrangements that they sit with each other or next to each other. Okay, to do that, okay, we're going to use or these two boys as one block. It means that instead of 6, okay, instead of 6, so we have what? Three boys, tama? And then 3 girls. So instead of these two not sitting with each other, we're going to treat them as if we will count how many ways are they gonna be sitting together. Okay, and then subtract it with the total number of constraint of no or total number of possible arrangement. Then we will get all of the possible arrangement they are not sitting with each other. Okay, now to do that, we're gonna be counting them together as one, and then everything will be for each other. So we have n equals to 5 in total. So to get that, we have 5 minus 1 factorial equals to, so there are 24 arrangement that they will be sitting with each other. So within the block, okay, of course, for each block, right, they can switch with one another. So there are 24 times 2. Okay, because they will be sitting with each other and then they might sit on the left or the other one to the right. Okay, so they can switch places. So there are 48 possible arrangement in total. Okay, now to determine, okay, so all of these 48 are the possible arrangement that they are sitting with each other. Okay, whether they are on the left or the other one is on the right. Now, to get, it means that among the total number of ways or number of arrangements, no, among the total, if we subtract the total number that they sit with each other, what we will get is the number of, the number of ways or the number of arrangement that they will not be sitting with each other. Determine the number of ways that they won't sit with each other. So we have what? 120 minus 48 equals to 72. Okay, makes sense? So we have what? 72 ways to arrange these two boys, no, not sitting with each other. Okay? So hope this makes sense. Okay? So you get copy of this one because I'm gonna be erasing it in a while because I only have a little board. Okay. So I'll be erasing this one. Okay, next we have two boys and girls. Okay, are alternate with each other. Okay. Okay. So what we're going to do is we're gonna be arranging them. Okay, in such a way that let's first fix them together. So we have three. No? So we have three people fixed. Okay, then we have the girls. Okay, the three girls sitting. Okay, in a alternate manner. Okay, so this is for letter C. Okay, so um, if they are two boys alternate, we need to fix the position of either boys and girls and then place the other gender in the remaining position. So there are three boys and three girls, so we have one. Okay, so arrangement of the three boys. Arrange the three boys. Okay, in total, there are what? 3 minus 1 factorial or 2 factorial equals to 2. So there are only two ways to do that. Okay, because if they will be arranged in a circle, one will be the reference, the two will be moving. So there are only two ways to do that. Okay. So next is that we need to arrange the girls or the remaining girls on the remaining three positions. Okay, so there are what? There are three girls. Okay. Arrange the three girls on the remaining seats. So we have three girls, right? And then we can, move them around, right? We can move them around. Okay. Oh, okay, so there are 3 factorial. Okay, now we multiply them together. Of course, as part of our counting technique, there are 6 ways. I sorry, 6. 3 factorial is 6. Now there are 2 ways to arrange the boys and then 3 ways to arrange the girls. So for them to be able to count using counting techniques, you have 6 times 2 equals to 12 ways to do it. Okay, the 6 came from here, the 2 came from here. Alright, so there are 12 ways to arrange them, okay, with boys and girls alternating. Alright, so I'll be erasing this in a while, so try to copy them together. Alright, together with your notes. Okay, so we have what? Letter D. So letter D, the 3 boys, okay, and 3 girls form 3 couples each and they are to sit beside each other. Okay, so I think this one is quite a little bit easier. Okay, because what we're going to do is, let's erase this. For each couple, we're gonna be doing is, um, we're gonna be using them as one block. Okay, so for each couple, okay, so let's say couple 1, so they will be arranged in the one block. So this is 1, and then, okay, 2, and then 3. So, we consider them as 1 block, 2 block, and then 3 blocks. Okay? So, ay, ay, okay, 1 block, 2 blocks, and 3 blocks. So, you have you have, and they are to sit with each other. Okay, so, next to each other. So, we have, um, 3 minus 1 factorial equals to 2 factorial equals to 2. Now, within each couple, the boys and girls can switch places. Okay, so for each one, so we have, for each one, so we have 2, 4, and 6. So, we have, they can switch places, diba? So, we have 2 times 2 times 2 for each one. So, they can switch places. Okay, so there are a total of 8. Okay, now, we can multiply them together as the principle of counting techniques as 8 times 2 equals to 16. Okay, this makes sense. This is one is the circular logic or the circular permutation. Okay, the other words are ano na lang, permutation pa rin. Alright, but simple permutation na lang yan. Okay, so copy it. So 3 minus 1 factorial, 2 factorial is equals to 2. And then for each couple, they can switch together, no? Switch each couple. Okay. So let's have the one, letter D. Okay, I'll just erase this. Okay, all boys and girls are together. So if all boys and girls are together, okay, we're gonna be treating them, each one, as what? One block. Diba? So all of them are 1. This one is 2. Right? So we have, for that one, so we have, 2 minus 1 factorial equals to 2. Alright? Oh, sorry. Ano pala to? 1 pala to. Sorry, factorial. Is equals to 1. Okay? And then within each block, okay, for each block, so we have 2 blocks, no, sitting in arranged manner. Now, so for each 2 blocks, they can actually, shuffle each other. Okay, so for this one, we have, for the first block, we have 3 factorial. And then for the other one, is we have, 3 factorial as well. So this one is, 6 times 6 equals to 36. Now, those 36 permutation, you will be multiplying with regards to the, circular permutation arrangement, which is what? 1. Ay, nangyari. Which is 1. So we have 36 times 1 equals to 36. Okay, so there are 36 ways to arrange, uh, all boys and girls will be sitting next to each other. Right? Question? None yet? Okay. So, okay. So, next is that we have what? Um, all boys and girls are together. B1 and B2 will be sitting next, should sit next, opposite each other. So, it will look like this. Okay, whatever that may be. Okay, so we have what? If B and B, If B1 and B2 will be sitting next to each other, okay, we have to have a fixed point. Okay. Now, since there are ilan man total? For 6, no? So, out of the 6, 2 are already occupied. No? Thus, there are only 4 factorial times 24. Okay? So, ito yung total number of possible um, arrangements for B1 and B2. Okay? Alright. So, I think those are the examples na lang. Okay? So, I'll be seeing you in the next video. Okay, as I record it. Okay, so this one is for circular permutation. Thank you very much, and I'll see you soon.